Well, hello everyone. This is KP the Math G again. We skipped yesterday because, well, it was Valentine's Day, and that time belongs to my wife and I. So um, we just naturally had to skip a day. That's okay. We're back at it again, and we're looking at the 1999 test, the free response, the very first question. There are 4 parts to this one, and we're just going to only look at the first 2. I've noticed in the last couple of videos, and I do apologize if you didn't get a chance to see my comment from the last video. I had made a mistake, and I went over it again, and I finally got it, but it was already my camera, after about 31 or 32 minutes, will go out on me. So just stop, and I don't even have a chance to give my signature clap. You know me, if you've seen my videos, I clap right at the end. If you have not seen it, you will hopefully see me do my signature clap at the end of the video. I like to do that. That's just me. I don't know why. It's just something I got started doing, and I haven't stopped doing it yet, so I'm just going to keep on doing it that way. Alright, 1999, a free response question 1 says this. It says a particle moves along the y-axis with velocity given by v at t equals t sine t squared for t greater than or equal to 0. It says, in which direction, up or down, is the particle moving at t equals 1.5? Why? Well, now, let's see. What does this say right here? V at t, doesn't it? Alright. And when we're talking about in which direction, up or down, we need to know v at 1.5. I know when I first looked at calculus problems, I'd have to study to find out if I needed to take a derivative or a antiderivative, and I wasn't always sure. But you know, it says when in which direction, okay, up or down is the particle moving at t equals 1.5. So when we talk about movement and in some direction, positive or negative, up or down, we're looking at the velocity. Okay, so let's go ahead and, without further ado, let's find that. So v at 1.5. Alright, that is equal to, and just plug it in now, 1.5 sine of 1.5, and you can put the squared on the inside or on the outside. Since 1.5 is already positive, it's okay to do that right there. I would suggest that you do get into a habit, though, of just, if you want to, just doing that, because if it were negative, but we already talked about t being greater than 0, greater than or equal to 0, and that's okay. We don't have to worry about whether the square is on the inside or on the outside. Alright, now you plug that in, you get an answer that is approximately equal to, and see, I did it, I wrote all these things down, 1.167, 1.167. So what does that say? V at 1.5 is greater than 0, isn't it? And, well, if it's greater than 0, then we know, alright, for this reason. Do we have to say why? Yeah. And for this reason, particle is moving up. At t equals, we know where it is. That's probably as good as it can get right there. And we just say because b at 1.5 is greater than 0, and for this reason the particle is moving upward at t equals 1.5. I don't even know if you need that because you already know v at 1.5. Okay, that is the first part right there. Okay, I'm going to try to make these videos a little bit shorter because the last couple of times I've got to my 31 minute and 25-second limit somewhere along there, and after that it shuts off. Okay, but I appreciate you still tuning in. I appreciate that very much. It means a lot to me, and I do these because I really have fun doing it, and it helps me learn. It keeps my mind sharp, and I enjoy doing this, and I enjoy helping people learn this. And of course, for those of you who are in the AP classes, you understand that you are going to have a mock exam coming up. I want to say March. I don't know if they changed that or not, March or April, and then I don't know when you're having your exam, May maybe, I'm not sure. Things change. I have not taught this in a while, but that's what we used to do, and I'm thinking maybe I'm just basing it on what I used to do or what we used to do before. Alright, anyway, that's the end of the first question. And that's no slight on those of you who are taking just regular calculus. You need this as well. Okay. Alright, let me go ahead and turn this over. And we have question B. Now it says find the acceleration of the particle at t equals 1.5. Let's look at this again. We have velocity v at t is equal to t sine t squared, and I want to say that is it. Yeah, okay, for t greater than 0. Okay, but anyway. Alright, so let's see. It says find what? The acceleration. Now, derivative or antiderivative? Which one? You're finding the acceleration. Derivative or antiderivative? That's exactly right. It is the derivative. You've taken the derivative. The derivative of the velocity is the acceleration. You probably can do it on your calculator, but this is doable by hand. And I'm going to do just that by hand. Let's get another color. Alright, so V prime at t, which is A at t. Alright, now this is product rule, isn't it? Alright, so let's see. The first, and you can do it in any order you wanted to. You could take the derivative of the first times the second. I'm going to do the first. The first times the derivative of the second. What's the derivative of sine? That's right, cosine. Cosine t squared. Is that all we do? And again, you're right. No, that's not all we do, because we have a chain rule here. Times 2. Alright, there it is, right there. And we can rewrite this in just a moment, but there it is. Now that's part of it. Now remember, we have plus the second derivative of the first times the derivative of the second plus the second, which is sine t squared. Now the derivative of t is 1, isn't it? So let's clean this up just a little bit. T cosine of t squared. Actually, this is 2 times that, so 2t. Alright, there it is. Plus sine t squared. Alright, let's see what needs to take place here. Now let's think about this. Is the velocity increasing? If v at t, b prime at t, if b prime at t is less than 0, which is a at t, then this velocity is decreasing, isn't it? Decreasing. Alright? Now if b prime at t, the derivative is greater than 0, then the velocity is increasing. Alright, that's what we're talking about. Alright, that's what we mean here. Let's see which one it is. We want, let's see, I'm going to go ahead, I think I can do this. Let's see, v at 1.5 is equal to 2 times 1.5 cosine of 1.5 squared plus sine 1.5 squared also. Now you would think that because a number is squared and a number is squared and everything is here, this is going to be positive. But you got to remember, you're dealing with cosine and you're dealing with sine. I mean, sine could be positive or negative. Cosine could be positive or negative. So something, let's see what happens if we plug that in. And when I plug this in, I get negative 2.49. So this is equal to, or about equal to, negative 2.0. Let's see what I have here now. 0.049. 0.049. One thing that, one thing that we need to, and this would be, of course, and I don't know if I don't think we need to worry about the units. They don't have any units for us to worry about. So feet, meters per second, or meters per second squared. So we don't have any of that. Alright, so that is what we are looking at right here. Yeah. And let's just take a look at this. A at 1.5. And this is it right here. Now sometimes if they were talking about speed, it would still be if something speeding up or slowing down. Well, we just found that if we had that question, something that deals with speed, is it speeding up or slowing down, the velocity is equal to, is positive. Alright. Well, hold on a second. Okay. Yeah, I just want to kind of put this on the side, a little side note. If we're talking about speed, alright, is speed increasing or decreasing? Alright, so from the last problem, we had v at some number, right, in this case v at 1.5 was greater than 0, but a at 1.5 is less than 0, so the particle is slowing down. Alright, slowing down. Alright, and that would be if you're talking about speed. This one here says, is the velocity increasing or decreasing? Well, remember, when you take the derivative of something and we see that that is less, if that derivative is less than 0, then the velocity is decreasing. So they didn't talk about speed here, just velocity. So just kind of keep that in mind, that if v prime, if the derivative, which is a at t, is less than 0, then this is so because v at 1.5 is negative, then the particle is decreasing. Isn't that what they're saying? Well, the velocity, not the particle, the velocity. The velocity is decreasing. Sorry about that. Okay. The velocity is decreasing, and not v, but v prime. Okay, which is a at t. If you said a at that, that's okay. That's quite all right. So we have to be aware of what they're asking for. If they were asking for speed, you would have to compare. Just keep in mind, for speed, the velocity can be both, the velocity and acceleration can be both positive or both negative if it's going to be speeding up. If we're talking about speed and the particle is slowing down, then we're saying then that either v is greater than 0 and a is less than 0 in this case, or v is less than 0 and a is greater than 0. Alright, so that's what I'm saying. And in this case, they're talking about, is the velocity increasing? Well, again, same idea. V at t is indeed less than 0. It's negative, and so the velocity is decreasing. So that is what we're talking about here. It's definitely decreasing. Okay. Well, that's all I want to give at this point. We got into velocity, which we already had the equation for that, so we didn't have to do a derivative or an antiderivative on this first side right here. Okay, if you're talking about direction up or down, you're talking about velocity, that is all you have to do right there. Okay, and then on this side, talking about acceleration, find the acceleration, so you have to do that. You have to be able to find that. And I do have the point system for that, I do believe. So far, based on parts A and B, part A is just 1 point, answer and reason. Part B is 2 points, finding A at 1.5 and find the reason. So far 3 points. I want to say there's another 6 points out of both C and D, and I'm just not going to take the time to do that. I want to reserve that for a good reason. Okay, we will do C and D in the next video, so if you want to tune into that, we will do that. I do have another one that I want to do, maybe one or two more, and then we'll get into some more concepts. But I am really just wanting to prepare you for this upcoming test. I guarantee you, if you watch all of these videos that I've showed you here, I think you're going to pick up something here, and perhaps maybe this will help you get a 3 or a 4 or even a 5. And that's really my purpose. And even if you are just taking calculus, this will help you understand what you're doing. So what you need to do in the class, and to learn this for yourself. Okay. All right. Well, that's all I have. Please, if you will, if you are a new viewer and you have not subscribed, please hit that subscribe button. I'd like to see some more subscribers, but then again, if you decide, well, I don't care about subscribing, it's okay. As long as you learn something here, that's all that really matters to me. But it would be nice if you did subscribe to it. And if you want to hit that like button, or if you want to make a comment, please make a comment. Feel free to do that. And if you feel like I could have done something better or said something a little better, please tell me what I could have said or done better, and I will change it, provided that what you say is correct, and that's only fair. But anyway, I just want to help you be the best that you can be, and I want to be the best that I can be at this as well. Okay, that's all I have for now. This is KP the Math G signing off, and as I promised, I'm going to give that signature clap, and here it is now.